So I've got a new antenna design that I want to share with you in this video. It's a double biquad that I've designed specifically for FPV at 5.8 gigahertz. Now it's pretty unique because what I've done, I've bent the reflector as you can see here, and what that allows the antenna to have is a much wider beam width, which is what a lot of people who fly FPV, especially quite close in, want from an antenna. They want quite a bit of range, but they also want a much wider beam width, and sometimes that's pretty difficult to achieve with some antenna designs. So I came up with this design after I made the latest biquad build that I released. I filmed it in between Christmas and New Year, but I only released it a week or so ago. But this is the idea that I came up with off the back of that design. So it's going to be a bit of a long video. I'm going to show you all the steps that are involved to produce one of these double biquads for FPV. So let's jump straight into it then, and I'll show you some of the materials you're going to need on the bench. So the main body of the build for this antenna then is some aluminium tubing. Now this aluminium tubing I picked up off eBay. You can pick up meter lengths of this pretty cheaply, and it's 34 millimeters in diameter with a 1.5 millimeter thick wall, and you need to cut off a section that is 100 millimeters in length. Now the next thing you're going to have to do is cut the tubing in half. Now if you've got access to a bandsaw, pretty straightforward to do it on a decent bandsaw with a metal blade. I cut this in half using the Dremel and a cutting wheel, but again, even if you've just got a hacksaw blade, as long as you take your time, it's quite soft material is aluminium. Well, this aluminium is anyway, so it's not that difficult to do. So I think we can move on to the next part of the video, because I don't have to show you how to cut a piece of tubing in half. So once you've cleaned your reflector up a little bit, I've just rounded off the sharp edges here and got a little bit of emery paper. I mean, we are going to be painting this, so you don't have to get in there and polish it up. But I've got a piece of brass here, and you can use brass, copper, a piece of tin from a cookie tin, something like that, recycled. It doesn't really matter. You just need something that you can solder onto. Now, so what I'm going to be doing is cutting off 100 millimeters of this brass tubing here. I can't remember how wide this brass tubing is. It's 25 millimeters wide, and what I'm going to be doing then is using all my marks where I'm going to drill the hole to rivet this on the back of the brass here. So I'm going to cut this off at 100 millimeters. So I've marked off where I want my holes on the brass strip here. I've also punched them out as well to make them a little bit easier to drill, and I've written on here the measurements that these holes need to be at. Now the first hole is going to be for the connection for the coax, so that's in the center of the strip. The hole here near the side is the one that's going to be the nylon post that supports the element itself, and that's 15 millimeters in from the side here in the middle of the strip. The next one is the hole for the rivet we're going to use. The rivets are 3.2 millimeters thick and 5.5 millimeters long, so the rivet is going to go in here, and that's 28 millimeters from the side here. So basically we've got a hole for the rivet here, and then we've got a hole for the nut for the nylon support to hold the element in place, and the same on the opposite side there. I am going to be connecting this double biquad here with some semi-rigid coax, so we're going to do something a little bit different than what we've done on this one. But basically that's where you want to drill your 5 holes here, and I'm going to be drilling the middle one a little bit wider because I'm going to be using some copper tubing to attach the semi-rigid coax to. But these 2 holes here and these 2 holes here, I'm going to drill with this drill bit here, which is 3.4 millimeters in diameter, so just a little bit bigger than the rivets themselves, and that's plenty wide enough to connect the nylon post to as well. So I've got all the holes drilled in the brass plate now, and I'm going to use this much thinner brass tubing here. This is 5mm in diameter. It's just a little bit thinner than the copper, so it's quite easier to work with and solder in place. Then basically that's going to hold this semi-rigid coax, add some strain relief, and just hold everything nice and secure in place. And I've drilled a hole through the brass plate there, the same diameter. So what I'm going to do now is attach this to the reflector with some masking tape, and then use this as a template to drill the holes in the reflector. But then what I'm going to do is remove this and then cut the little slits down the side of the reflector to get that angle in there, to get that much wider beam width. So before we go ahead and permanently attach the brass strip to the aluminium reflector, we need to cut out a slot like I have here, so that will enable us to bend the reflector back to increase the beam width of the antenna. Now I want to leave about just over 10mm, 12mm width across here and here that I don't cut into. And one thing you can use to help you get a nice straight line around this curve is get the second reflector that you cut, the opposite side of the tubing here, place it over this one, line it up about center with this riveted hole that we're going to rivet in place, and then you can draw a line down here and it'll be nice and straight like so. And you can do the same on the opposite side as well, and that'll give you a nice guideline then where you can cut out your slot. But remember, we need to leave about 10mm or 12mm here and here where we don't cut into, and that will enable us to bend the reflector back to get that increased beam width. So I'm now ready to start cutting the slits, and if you've got access to a bandsaw with a metal cutting blade, it's pretty straightforward to do on a bandsaw. Unfortunately, I'm waiting for a metal cutting blade for that, so I'm going to use the Dremel. Just have to be careful that it doesn't jump, and make sure you use the Dremel away from you. But I've got it held in this vise, so what I'm going to do first is just score a line where I'm going to make my cut. And now I'll cut into it following that line there. It'll help guide my Dremel cutting tool here. So now that we've got the slits cut in the reflector, I've also gone ahead and deburred the sides with this small file here. Just gone in there and ran it across each cut that I've done. It just helps to deburr any sharp edges on there. But as I say, we're going to be painting this, so you don't have to worry too much if you scratch the aluminium. But I'm going to rivet the aluminium plate into place now, and then we can put the bend in to get that slightly wider beam width. And I'm going to put the best side of the rivet on the inside of the reflector here, because that's the bit that's going to be on show more than the back of the antenna, just to give it a clean look to the construction. So I'm ready to start bending the reflector to give it its wider beam width here, and you want the widest gap of the slits that we've cut in to be around 4mm. Any greater than that and you won't fit the element on neatly, and 4mm seems to be just about right. So slowly I'm going to bend these. I'm going to use a flat screwdriver here just to help me, and slowly bend them out. Just a little bit more. So that's about right, about 4mm. So now I just need to do the same on the opposite side. So I'm going to solder the brass tubing onto this piece of semi-rigid coax that I've got here. It's about 90mm long, and I've prepared it here. I've got just under 10mm of the inner core exposed. I've left a couple of millimeters of the dielectric between the outer braid and the inner core there, just to add a little bit of insulation so we don't end up shorting our antenna out. And I'm going to solder the tubing here, just here on the semi-rigid coax. Now you may see that this tubing is a little bit wider than the semi-rigid, and I'm just going to solder it on this side here. I'm going to leave this side alone because when we come to attach the element later, I want to be able to stick one of these legs down into there and then attach it with a little bit of solder. So I'm just going to solder it at the side there and also solder it at the bottom down here. So that's the tubing soldered in place there, and I want to show you this detail here. I've basically, as I said, haven't put solder on this side of the tubing here, and I've got a 1mm drill bit drilled a small hole down in between the coax and that tubing there, and that'll give me a nice solder point then to, you know, place the tube into that hole and just melt some solder around there, and it'll just anchor it really tightly. You know, just going in there and making that hole to give it a good solder connection is just a small detail I want to show you. You can also start it off by one of these little picking tools here, but I've gone in with a 1mm drill bit just to, you know, take it down a bit further and anchor it really well in there when we come to attach the element itself. So what I'm going to do now is solder this to the reflector, and then we can put some paint on the reflector. So that's the brass tubing soldered in place. It is a little bit too much to ask for a soldering iron, but basically what I did is get the solder in place around the metal tubing with the soldering iron, and just put some flux in there and get a little small blowtorch like this, get some heat around the brass plate and the tubing, and it will flow in the end around there. So we've got a good secure connection there now with the antenna and the coax. Also, you could build this with the semi-rigid without the tubing, but I don't think, you know, because of friction and everything else, without that little bit of strain relief that the tubing gives you, it will probably end up snapping off. But what I'm going to do now is let this cool down, just clean that area up a little bit with a wire brush, and then put some paint on this, because I do like the contrast you get with the black paint and leaving the brass element as it is. So next we're going to build the double biquad elements themselves, and for the elements you can use copper wire. This is some copper wire here. It's around 1mm thick. I wouldn't use anything thicker than this, but the trouble with copper is it's very soft. So if you do want to build a double biquad out of copper for the elements, you really want to come up with some way of protecting those elements. So what I'm going to use is this brass wire. It's 0.7mm thick, but it's much more springy, and it holds its shape a lot better if you do impact it on anything, because it's pretty, you know, much more difficult to bend out of shape than this copper wire here. And between the two, you know, as far as electrical conductivity is concerned, there's not much between them at all. So I'm going to show you the complete process of making the double biquad element then. And we're not going to use a ruler. I've shown you in previous videos how you can use a little measuring tool like this. This is something that I've cut out in cork. I did have a set of perspex that somebody cut out with a laser cutter for me, but I just can't lay my hands on them. I don't know where I've put them. But the measurements that I'm going to use is the quarter wavelength, which is 12.9mm. That should put us bang on 5.8 gigahertz. And we need a double wavelength measurement here, and this is double. Obviously it's 25.8mm long, and we're going to use this to help us measure off the elements. It's just much easier doing it this way than using a ruler and marking off all the sections. And I'm going to be using my favourite pliers for this job here. I like these ones because they've got a big flat surface here that I can butt the measuring tool up to to put the bends in place. And unfortunately, because this pack of wire that I've ordered did get bent in the mail, I'm going to be starting off here so I'm not wasting too much. I'm going to put my first right angled bend just here. So your first right angled bend wants to go in, and you don't have to measure this first bend, but you do want to make sure you've got at least 15 millimeters in length here that you've got to play around with when you're connecting your element up. But because this is bent, I've got a slightly longer piece there. So first of all then, we want to do a quarter wavelength measurement here. So I'll just get my measuring tool, butt it up against my needle nose pliers like so. I'm just going to turn them so they're in that direction, hold it tight, remove the measuring tool and put a right angle bend in there like so. So it looks just like that. Now I'm going to do a half wavelength measurement, so again button it up to the flat surface on my needle nose pliers, get it positioned, remove it, and I'm bending it in this direction. And the next measurement, you can get pretty quick with this. The next measurement is a quarter wavelength. Put it up like so, and this time I'm going to come in to start forming that bow tie element shape that you get with the biquad. So next is a quarter wavelength. I get it like so. I'm going to bend it in on itself this time. You can see how much faster using that little measuring tool is when it comes to building these biquad elements. I'll just go in and tidy those right angles up a little bit. So we've now got our element looking like this, and to be honest with you, at 5.8 gigahertz the measurements are so small, I don't think you'd be able to do anywhere near as a neat job and be totally accurate with all your measurements using a ruler and something like a Sharpie. I think it's only possible with a measuring tool like this. So next we need another half wavelength. I'm going to bend it in. Being really careful here in that direction. I'm just going to tidy up. Like so. It is very fiddly, especially doing it on camera like this, but you get the general idea. So now another quarter wavelength measurement. Bend it out like so, and you can see we've already completed half of the element there. Another quarter wavelength. And what I suggest you do is when you're doing this is get a picture of the elements in front of you if you're not used to building these. I mean, even me sometimes, I've got this element here just off side of the camera just so I can follow it, so I get my bends in the right direction. It's pretty easy to go in the wrong direction, especially when you're building the double biquad. So now we need a half wavelength measurement. Right angle bend. Now we're going to be bending in on itself to come back. So quarter wavelength. And another quarter wavelength. can go ahead and tidy up those right angle bends to get them much sharper. And we're almost done now. It does get a little bit fiddly towards the end, but we want another half wavelength measurement. So, and now for the final measurement, we need to do a quarter wavelength and then bend the rest of this down. So I'm going to trim away some of this. We don't need all of it, and it'll just get in the way. So trim about that much off. I'm just going to feed that underneath there. Do a quarter wavelength measurement, then bend down. So that's the element made up. So what I'm going to do now is just go in and tidy up my right angle bends, and basically that's how easy it is, especially when you've got one of these little measuring tools to help you. So what I need to do now that I've formed the element is I need to put some heat shrink tubing on here. So you see where it crosses over on the element, I don't want it shorting out, because if it shorts out it's no longer working as intended. So I use a little bit of heat shrink tubing and I put it under the element that runs under the other element there, like so, and you can just feed this on. Feed it up and through, and I don't fix this in place until I've got the element fitted onto the reflector as well, but you can see there now that it's no longer shorting out where it crosses over there, and the heat shrink will stop that from happening. I also put a little bit of super glue on the heat shrink and then shrink it down just to make sure that it doesn't move, and I'll put one on the opposite side as well. So as you can see, I've got the elements held down with masking tape onto this piece of wood, because I'm now going to solder these two legs together. You can see I've cut one of the legs down because I don't need all of that length, but if I were to just solder this together as it is, when it comes to fixing it to the reflector and I need to solder this leg onto the coax, as soon as I put heat into this leg, it travels up and it will desolder this and it will just spring apart. So what you need to do is solder these two legs together and then get some of this fine wire off of coax, strip it out into a short length, and what I'm going to do is wrap that around those two legs. Put solder on it first, wrap this around those two legs, and then solder that in place again, and then that will stop the two elements springing apart then when you put heat into this leg to solder it in place. So a little bit of solder on the legs, just check that they're nice and straight, the length of the wire. Hold that down with solder, and now I can just wrap this around the leg. And you can also tie it off a few times as well, just to make doubly sure that it's not going to spring out as soon as you desolder it. Add the heat into there. So now we're ready to put the element in place. So what I've already done is put one of the posts over on this side. I'm about to put the post on the opposite side, and these posts are little nylon standoffs. You can buy these as a kit with various sizes on eBay, and you're going to need a screw, a nut, and one of these standoffs. These standoffs are 10mm long. Now, the distance the element needs to be from the reflector at a 5.8 GHz biquad, I think off the top of my head it's around 6.5mm, 7mm I think, or around that kind of size anyway. But what I've done, because this is curved, I've taken it as an average and I've set the element 10mm away from the back reflector. So I'm now going to use one of these posts. I'm going to insert this one in here, lock it off on the back with the little nut, and then I can insert the screw onto this side like I have done here, and then we can start and attach the element to the reflector. So I'm about to add the element to the reflector, but one last thing I want to do before I do, to make it easier for me, I just want to tin up this point here on the element, because that's where we're going to solder it to the center core of the coax there. So a little bit of solder on there just to pre-tin it. And I've also cut the leg down to size that's going to fit in the hole that we made with that brass tubing and the coax. So this is the fiddly part, but basically I've got the screw connected on this post here, so I'll put the element around the screw there. That leg is going to go down into the hole that we made, and what I'm going to do now is stretch the rest of the element out and then put this screw in on this side. It is a little bit fiddly, but a little bit of patience and it's not too much of a problem. Finally, I've got a little bit of solder on the end of my iron, and just apply a little bit of heat into the leg and the solder should flow. And this is why it's important to wrap that wire around those two legs, because this is the point where it would just spring apart. So now I'm going to tighten both of these nuts down and then straighten it out, and then permanently fix the heat shrink tube in here that stops it from shorting out in place. So that's everything in place now, and you don't want to tighten these screws right down, otherwise it'll make the element jump out of that little gap. You just want to tighten it down so it sits on top of the element itself, and then finally do one last visual inspection around here. Make sure you haven't got any solder grounding anything out and shorting anything out. And basically I'm just going to put a little bit of epoxy putty in there just to protect the elements, make it look tidier, but also to make sure to keep these two points here separate, and then get a little bit of black paint with a paintbrush and then just touch up around here with the black paint. So this is the biquad ready to be tested on the spectrum analyzer. We're testing return loss at the moment just to see how well it works on the 5.8 GHz frequency, but if you have a look at the screen, it's looking really nice. And here it is on the spectrum analyzer then. I've got it centered on 5.8 GHz down the center line here, and you can see why I and a lot of people do love biquads is because they're so wide on their frequency of operation, which does mean, you know, if you're a little bit off with your measurements, you have got this quite broad area to play with. So, you know, if you get it off slightly, if the cutoff point's here instead of over here, you know, you can still hit your mark. But that's a really nice response, and that's going to be such a low VSWR. It really is going to operate fine at 5.8 GHz, just a little bit over, and quite a lot below that as well. I mean, I am pretty happy how this antenna has turned out, but possibly in the future I may play around with the measurements slightly to try and shift this a little bit more that way, just to give a little bit more frequency operation around this area here. But you know, as it stands, that's going to be a pretty good antenna. And if I change the resolution slightly so you can see it over the band a little bit more, you can see how you've got that nice dip in this area here. So this is the full band here, so it's no longer centered on 5.8 gigahertz now, but it's just off to the side a little bit, and this is its response just here, because it's showing the full frequency span from what have I got it set at, 3.8 to 8.5 gigahertz. So it's just sitting there. It's a really nice response. So I'm pretty pleased of how this design has turned out, and with the thick aluminium there, it should have a really good front to back ratio, so it should perform really well, especially with that frequency response on the spectrum analyzer. But as some of you have been with me for some time now will know, that I don't actually fly quadcopters, so I can't do a live field test, as it were, but it should perform really well, and it should also perform well with this biquad omnidirectional antenna. I believe I made a video of how to construct this some time ago now. I've never sold this myself, but somebody has been selling these for the past couple of years since I made that video on eBay, and he seems to have quite good feedback on the performance of these. But you know, in conjunction with this, it should work really well. So I'm going to put a few in the eBay store, and I'm going to include one of these with it as a kind of kit, if you will, and just see how they go. But they are pretty labor intensive to build, and I've noticed there's a couple of Chinese manufacturers selling the double biquad for 5.8 gigahertz, so possibly get a few of those into the lab as well, and take a look at them, see how well they perform on the spectrum analyzer. And I'll get the network analyzer going as well. I haven't used that for quite some time, but I'll start using that more in videos to test some of these antennas as well. But no, I really like that design, and swept back as well, so you get that wider beam width that you really need for quadcopters. And I've also made a single biquad as well. It's not going to perform as well as this, but it's just a little bit smaller, so I'll put a couple of those in the eBay store as well. But you know, as a 9 dBi antenna, it's going to perform really well. And again, because it's made from the same aluminium tubing, because of that thick aluminium reflector, it's going to have an excellent front to back ratio. And then again, when used with one of these antennas, it should perform really well. But remember, it's linear polarized as well. It's not circular polarized, and to be honest, I don't think there is any way you could make a circular polarized biquad antenna. I've never come across one, and I've never researched, to be honest with you, to see if you could make one. But off the top of my head, I don't see how you could. So hopefully you've found this video useful, and you have a go at making one of these yourself. I've tried to include as much detail as I can so you can follow along and you know, produce one of these yourself. You don't need any kind of specialist tools really. You know, just get the materials off eBay, and you know, any kind of rotary tool. It doesn't have to be a Dremel, and you should be able to knock one of these up in an afternoon. But it is a little bit labor intensive. I mean, obviously filming it did take me quite a long time, but even just making these, it does take more than a few hours. So if you did enjoy the video, please give it a thumbs up. Any comments or questions, drop them below, and hopefully you'll join me on the next one.